Hello and welcome. So let's look at few questions from linear algebra from computer science branch year 2022. So we have first question, that is question number 45. What we have given is consider solving the following system of simultaneous equations using LU decomposition. We have given this system of equations, and where we have given that this L is lower triangular matrix and this U is the upper triangular matrix. So this is the lower triangular matrix and this one is the upper triangular matrix, right? So what we have to find is these elements L32, U33, and also we have to find the solution, not the complete solution, but this x1, not x2 and x3, right? So let's find how we can do that. First of all, write this system of equation in matrix form. So we can write in augmented matrix form, right? So it will be 1, 1, minus 2, and 1, 3, minus 1, and 2, 1, minus 5, and we can put here right hand side, that is 4, 7, 7. Now how we can achieve this matrix U, right? So we have to achieve this matrix U, that is upper triangular matrix. So how we can achieve that? By doing elimination, right? We are going to do elimination on this matrix, and these elements we will try to make them 0, right? So we can have the first pivot here and we can apply the elimination. And also what I'm going to do is I'm going to keep track of my all elimination, right? And once I have my complete elimination information in this matrix E, then what I'm going to do is take the inverse of this matrix, and that matrix will be U, right? So basically the funda is, if you have given some matrix A, you apply the elimination E, then you get the matrix U, right? And if you have some matrix U, then you apply the elimination, then you revert your operation, that is by using E inverse, then you will get A, right? So that is right. So and if you know the basic that a matrix can be written and you can decompose it in lower triangular and upper triangular form, right? So the point is that if you have this upper triangular and now you want to have this matrix A back, then whatever you have applied the elimination by converting this matrix from A to U, now you have to revert that whatever you have done in the elimination, right? And that you can use E inverse here, that will give you A, right? So this L is nothing but this A inverse, right? That is why I will keep track of my elimination thing, right? Elimination matrix, so that I can find the E inverse that will give me the L, right? So let's do the first elimination, and what we are doing in the first elimination is simply subtracting this row 2 from row 1 from row 2, right? So the first is going to be as it is, and the second row will be here 0, 3 minus 1 is 2, and minus 1 plus 2, right? So it will be 1, and 7 minus 4 is 3, right? So let's keep track the elimination thing. So we have kept the first row as it is, and what we have done, we have subtracted the row 1 from row 2, and and what we are going to do next is, so let's keep it separate. The first elimination we have done. The second elimination, what we are going to do, we are going to make this 0, right? And for that, what we are going to do, we are going to multiply 2 with this first row, and we are going to subtract it from row 3, right? So the second elimination, what we are going to do, we will have the first row as it is, second row as it is, and here what we are going to do is multiply with the second row by 2, and it will get subtracted from row 3, right? So this is what we are going to do. So here it will be 0, and 1 minus 2 is minus 1, and minus 5 minus 4, that will be 4. So minus 5 plus 4 is minus 1, and here we will have 7 minus 8 is minus 1, right? Now our goal is to make this matrix upper triangle, right? So what we can do is, now we can pick our next pivot. This was the first, the next pivot is this one, and we can apply the elimination again. So let's do that. So what we are going to do here is, our multiplier will be minus 1 divided by 2, right? So we are going to multiply this row by 1 by 2, minus 1 by 2, and going to subtract it. After multiplication, I'm going to subtract it from row 3rd, right? So let's keep track of this also. So nothing to do with the row 1, nothing to do with the row 2, and what we are doing here is, this will be 0, and here we will have minus 1 by 2. So here we will have 1 by 2, and we are subtracting it from row 3rd, so here it will be 1, right? Okay, now apply the elimination here. So it is going to be same as it is, also it is going to be same as it is, and here this is going to be 0, here it will be 0, and here minus 1 into minus 1 by 2, right? So 1 minus 1 plus 1 by 2, so it will be minus 1 by 2, right? And here it will be minus 1 minus 3 into minus 1 by 2, so minus 1 plus 3 by 2, that is 1 by 2, right? So okay, so that is all. Now we have our upper triangle matrix, right? You can see that this is our upper triangular matrix, right? And so we have achieved our upper triangular matrix. Now let's focus on this our lower triangular matrix. So if you carry out this multiplication, so that is going to be easy multiplication. So it will be again, the first row is going to be same as it is, right? Because if you multiply this one and this one, then we will have here 1, and again here we will have 0, and here we will have 0, right? The second row would be minus 1, and it is going to be 0 plus 0, right? And the third, this here we will have minus 1 to 0, that will be 0 and 0, so here we will have 1, and this 1, right? So yes, and this is going to be 0, right? Yes. And here we will have minus 2 here, and here we will have 0, and here we will have 1. Now you are going to multiply this one and this one, right? So let's do that. So we will go 1 0 0, and here we will have -1, and here we will have 1, and here we will have 0, and here we are going to get -2, and here 0 0 half, and here 0 0 and 1. Let me just quickly check it out that we have done the multiplication correct. So this elimination we have applied correct, and this elimination we have carried out. Yes, to eliminate this we have eliminated this and this, right? And we have used this and this, right? Yes. So I can say that overall multiplication is correct. Now this is the E, right? But you have to find the E inverse, right? So what will be the E inverse? You can do the calculation, and you are going to get the E inverse as here we will have 1 and 1 and 0, and here we will have 2, and here we will have 1 by 2, and here 1. So you can check this, that E inverse, this is E, right? And E inverse is this, and this is nothing but the L matrix. And if you see, this matrix is L, lower triangle, right? So we have our matrix, that is upper triangular, lower triangular. Now we have to find, now we can get these elements, right? So but let's find out this x1. So to find this x1, what we are going to do is, in this augmented matrix we are going to do the back substitution, right? So if you pick this row, then it will be 0 times x1 plus 0 times x2, and minus of half times x3 is equal to half, right? So x3 is going to be -1, and you can pick this one. So 0 times x1 plus 2 times x2, and here we will have 1 times x3. So x3 is -1, so -1 will be 0, and 3. So x2 will be 3 plus 1 is 4, and 2. So x2 is 2. Now let's find this using this row. You can find the x1. So here we will have x1 plus x2 minus 2x3 is equal to 4. You can put x1, x2 is 2, this one, right? And x3 will be plus 2, that is 4. So from here what you can get is x1 is equal to 0. Right? Now let's look at the answer. So x1 is 0. x1 is 0. So we have option, this cannot be because of x1 is 0 here, x1 is 0. Now let's look at this L32. So L, third row, and second column, that is 1 by 2, minus 1 by 2. So L32 is -1 by 2. Here we have also -1 by 2. Here we have also U33. So third row, third column. So U33 is third row and third column. So third row is this, and third column is this. So we have -1 by 2. So -1 by 2. So this cannot be answer C. The correct answer for this is 3. Right? Let me check it out that we have done it correctly. So 45, right? 45D. I think correct. Okay, so this is a complete solution. I hope you got the idea that how we have done this. Okay, let me proceed with the further question. That is one more question we have, that is 53. Okay, so this one is based on the eigenvalue, right? So if you know the concept that there are some kind of special vector, and if you multiply with that vector, you are going to get the same vector but with some scaled version, right? So what we call these vectors, that kind of vector, we call these vectors are the eigenvector, and this scaling factor is called the eigenvalue, right? So any vector that will satisfy this condition, then that vector will be called as the eigenvector. Which of the following are the eigenvector? So we have given this matrix A, and what we can do, we can go option by option, and we can carry out the multiplication matrix with our vector. And if we find this condition, then we can say that vector will be our eigenvector. So let's do that. So what we can do is, we are going to put here the first. So any vector, so you are going to put it here, right? So if you pick the first option, then you are going to put it here. So just to make you visualize that we are going to put on the right side. Now you can do so this is how you are going to carry out the multiplication, right? So I'm going to write it directly, that it will be 9 minus 6 and minus 4. The first element would be this, and so 8 minus 3 minus 1, and here we will have minus 20 plus 8 plus 5, and here we will have minus 32 plus 7 plus 12, right? So we can do the calculation. So it will be -1 here, and here we will have minus 4, right? Yes, and here what we are going to get is okay, I have made a mistake. Okay, so you see that we have here, and what we are going to pick, the third element is going to be, so we are not going to pick this one, right? For this calculation, AX is equal to, so we are doing this one, right? So now what we will have is 9 minus 6 and minus 4 and minus 8, plus 8 minus 6 and minus 1 and minus 20 plus 15 plus 5, and here we will have 32 minus 32 plus 21 plus 12. Now we are going to get, so here will be 1 and 1 minus 10, and here we will have 20 minus 20, that is 0, and here we will have 33 minus 32, that is 1. You see that we get the same. So it is 1 times sum. So this is going to be eigenvector. So you can carry out this multiplication, and you will get in form of some lambda times x, right? So you can do that calculation, and you will find that A, C, and D are the correct option. So that was all. So this LU decomposition was the good question. Okay, that is all from this video. Thank you.